All right, let's take a look at day two. So on day two of our exponent chapter, we are going to look at a rule called the product of powers. Now, if you think about what that rule means, that means we are multiplying two exponential expressions. Okay, so the rule is we're multiplying two things that have an exponent. All right, so let's look at the rule. The rule simply says that if I have a to the b times a to the c, that is equal to a to the b plus c. So what that basically means is when we multiply common or same bases, so if you notice, my a's the same in both, so I have a common base, both of them are a, then what I do is I take those exponents and I'm going to add them. So multiplying common bases, we add the exponents. So, for example, if I had x to the third times x to the fifth, I have my common base. So I bring that over. There's my x. I take my exponents and I'm going to add them together. And that would give me x to the eighth. Now, why does this work? Well, the reason this works is it's based off of our definition of what the exponent is. So if we take a look at x to the third times x to the fifth, remember x to the third means that we take x times x times x. X to the fifth means that we go x times x times x times x times x. So when you look at that, there are a total of 8 x's. So that is why the addition rule works. That's the product of powers rule. So when we multiply common or same bases, we add the exponents. All right, so let's give this a shot then. So if we look here at this first one, it says x to the seventh times x to the fifth. So I'm going to go x is my common base to the 7 plus 5, and 7 plus 5 is 12. So x to the 12th. On this second one, I have y to the third times y. So my common base is y. Remember that even though there's nothing written here, there is a 1, y to the first power. So y to the 3 plus 1 would get me y to the fourth. Okay, here on number 3, now we have two variables. So my first common base is x. So I look, I have 2 plus 3, which is going to get me 5. My second common base is y, and I have 4 plus 1, which is also 5. So x to the fifth, y to the fifth. Okay, now on number 4, you'll notice all of a sudden we have coefficients. Well, the rule doesn't say anything about coefficients because they're not part of the base here. The base on this one is x. So what am I going to do with the coefficients? Well, if you look at the problem, it says to multiply. So all we're simply going to do is we're going to take the 3 times negative 4, and that gets me negative 12. Then I take my common base of x, and I take the 5 and the 3, and I add those, and that gets me negative 12 x to the 8th. Okay, let's take a look at number 5. So on number 5, we start off, we have some coefficients again. So I'm going to multiply those first. So negative 7 times negative 3, that's a positive 21. Then I go common base to common base. So x squared, x to the fourth. So add those together. That would get me x to the sixth. My next one is y. I have y to the first, y to the second. So that's going to get me y to the third. And then I have w. I have w to the fourth, w to the first. That's going to get me w to the fifth. So 21, x to the sixth, y to the third, w to the fifth. All right, let's try this last one here. Last thing we look at, we have a coefficient here, but nothing on the first one. So I'm just going to bring the 5 down. Now I go common base to common base. So I have x. I have a 3 and a 3, so those would get me 6. Y, I have a squared and a fourth, so that's going to get me y to the 6th. And then my z is just going to stay z to the third because there is no other thing multiplied to it. So my final answer there would be 5x to the sixth, y to the sixth, z to the third. So just to reiterate again, when we're multiplying common bases, we add the exponents. If we're multiplying common bases and those bases have coefficients, the numbers in front of them, we just multiply those coefficients, the exponents we add. All right, and that is our product of powers rule.